In question 8, we're told a curve C has equation y is equal to x cubed minus 5x squared plus 5x plus 2. In part A, we're asked to find dy by dx in terms of x. The question carries 2 marks. So all we need to do is differentiate both sides of the equation with respect to x. On the left-hand side, we'll have dy by dx. On the right-hand side, we simply multiply down by the power and drop the power by 1. So x cubed becomes 3x squared. Minus 5x squared becomes minus 10x, plus 5x becomes plus 5, and differentiating a constant gives us 0. So final answer is 3x squared minus 10x plus 5. We're now told the points P and Q lie on C. The gradient of C at both P and Q is 2. The x-coordinate of P is 3, and in part B we need to find the x-coordinate of Q. dy by dx is the gradient function. So we're told now that the gradient at both P and Q is 2. So we can write 2 will be equal to 3x squared minus 10x plus 5. If we go ahead and solve this quadratic equation, one of the solutions will be x is equal to 3, and that corresponds to P, and then the other will be now the x-coordinate of Q. So 0 is going to be equal to 3x squared minus 10x plus 3. Using the linear factor of x minus 3, we can see that this is going to give us now x minus 3 multiplied by 3x minus 1. So we can see from here that x is equal to 3, which corresponds to P, and then we're going to have x is equal to 1/3, which corresponds to Q. So we could write now that Q has the coordinates 1/3, y. If you wanted to find the y-coordinate, we could simply sub 1/3 into the equation for C. We're only asked here to find the x-coordinate. In part C, we need to find an equation for the tangent to C at P, given our answer in the form of y is equal to mx plus c, where m and c are constants. The question carries 3 marks. A tangent is simply the straight line. A straight line we need 2 things for. We need a gradient, which we've got, that's 2, and a point that it goes through. We've got the x-coordinate of P, which is 3, and we can go ahead and find the y-coordinate by simply subbing in x is equal to 3 into the equation. So y is going to be equal to x cubed, so 3 cubed, which is 27, minus 5 lots of x squared, which will give me minus 45, plus 5 lots of x, which will give me 15, plus 2. So all I've done is taken the x-coordinate and subbed it in here to get these values. So we've got 27, then we've got 42, and then we've got 44. So we can see from this that y is equal to minus 1. So we've got our point and we've got our gradient. Using the equation of a straight line, y minus y1 is equal to m, the gradient, x minus x1. We can simply go ahead and plug these values in. You can, of course, use y is equal to mx plus c and solve for c. So I'm going to have now y minus minus 1, which is plus 1, is going to be equal to the gradient, which is 2, and then we'll have x minus the x-coordinate, which is 3. If we expand the right-hand side, we've got 2x minus 6 minus another 1. We'll have 2x minus 7. So that now is the equation of the tangent to C at point P. It now says this tangent intersects the coordinate axis at the points R and S. In part D, we're asked to find the length of RS, given our answer as a surd. The question carries 4 marks. If we just consider what's going on here, we've got now the equation of a straight line. If we look at this line, we can find where it crosses the x and y coordinate axis. So it's going to look something like so. So we've got the x-axis just here, and then we've got the y-axis just here. It's going to cross the y-axis when x is equal to 0. So if x is equal to 0, we can see this point right here would be 0, minus 7. It's going to cross now the x-axis when y is equal to 0. So 0 is equal to 2x minus 7. Adding 7 to both sides and dividing by 2, we've got 7 over 2, 0. So what we've got then is RS. We're looking for the length. All we're after now is the distance. The distance formula is Pythagoras. x1 minus x2 squared plus the quantity y1 minus y2 squared. So all I'm going to do is put the values in here, and we're going to go ahead and find RS. RS is going to be the square root of 0 minus 7 over 2, which we need to square, plus minus 7 minus 0, which we need to square. So RS is going to be the square root of 49 over 4 plus 49. Lots of different ways we can finish this off. We could now combine these two fractions. So RS is going to be the square root of 245 over 4. And we could write this now as RS is equal to root 245 over 2. At this stage, we could look to simplify now the numerator, and 245 is going to be 5 times by 49. So if we consider now writing this as a surd, we could write this now as RS is going to be equal to 7 root 5 over 2. We weren't asked to simplify our answer, and I'm sure you'd get the full marks if you left it as root 245 over 2. This is a surd answer written here in its simplest form.